Okay, continuing on with section 8.2, which would be law of sines again, but now we're doing the side-side angle, which is called the ambiguous case. Ambiguous meaning when you have side-side angle consecutively in a triangle, that does not determine one unique triangle. You can have multiple triangles, or what we call ambiguous triangles. So, the saying is back from geometry. Let's say you try to draw as good as I can here. An angle, or triangle, call it angle. And another triangle is at the same angle. Okay, let's get some colors going here. And let's say they have the next consecutive side the same length. Use some blue here, same length. And then the next side, so this angle is not necessarily the same. It's same angle, same side, and the next side is the same, but not necessarily the same angle. It's possible that this side could have a small angle going back towards this side like this. Try to draw the same length here. Which means this side is that length. Or since this angle does not, we know it's side angle. We don't know anything about this angle. Maybe it's a big angle, and let's call it the same length side here. Try to draw the same length side. It looks about the same. And you see that side angle, side angle, or say angle side the same, does not mean one unique triangle. It is ambiguous. You could have this triangle or this triangle, and that's what we have to watch out for when we have side angle or angle side. Okay, our first example here, this is going to be the situation when we end up with only one triangle for our answer. We've been given this information. Side A is 3, side B is 2, and angle A is 40. You might be saying, well, previously we did a law of sines. We had angle, side, or angle, side, angle, which means we were given two angles on one side. So this time we've been given two sides of angle. It must be side angle. What are you talking about, Mr. Pines? Why do you have to worry about that? Well, no. We need to draw this triangle because it could be, we don't know, it could be side, angle, side, angle, side, and that can be solved using law of cosines, which we'll do in the future. So, when you're first given the problem, you're given the information, I suggest you draw like a little starter triangle. We don't know exactly what the angles are or what it looks like. Don't worry too much about that. Just draw a triangle. Let's call it A, B, and C. 40 degrees for A. Opposite of angle A is side A, which is 3. And opposite B is 2, and we'll be given no other information. So when you're doing a problem, you need to draw it out and look and see. All right, we've been given an angle, and then what's next? Oh, the next side. We weren't given this angle, and then a side. So it's angle, side, or side, angle. And you use a trigger alarm in your brain. Oh, gotta watch out. Maybe this is ambiguous. Maybe we have more than one triangle. So let's solve for. We have a pair. We have an angle on its opposite side. Let's find side B. Let's go. The sine, or sorry, find angle B. Sine of angle B over 2 is equal to the sine of A, which is sine of 40, over 3. Okay. Multiply both sides by 2. Hey, calculator, 2 sine 40 divided by 3. You get the sine of angle B is equal to about 0.428, or 0.429. We'll stop there for now. Okay. We want to know what the angle is, though. The sine of some angle is 0.429. Use the calculator since it's not a special ratio value. Now we get two possible answers. B could be 25 degrees, 25.4 degrees, or could be 154.6. You can wait. The calculator, I used calculator, I only got 25.4. How are you getting 154.6? Well, let's draw a new circle really quick. This is the angle. Sine of some angle B is 0.429. Well, in the first quadrant, let's call this B. The sine of B will be this vertical distance here. But also, if we go 180 degrees, 180 minus b, we have the same answer. This is 180 minus b, and we also get 0.429. Okay, so this equation has two answers. The sine of this angle and the sine of this angle both give us positive 0.429. So I got 154.6 here by doing, or b is equal to 180 minus 25.4. And that was 154.6. So we need to check, could angle B equal 25 or 154.6? Well, there's only 180 degrees in a triangle. 40 plus 25.4, that's less than 180. So yes, B can equal 25.4. 40 plus 154, that's over 190 degrees. B can't be 154, it's too big. So this is not possible. We only have one possible triangle. B is 25.4 degrees. Which means we need to find angle C and side B. Triangle added to 180. C is equal to, let's put a box on this, 180 minus 40 minus 25.4. C is equal to, angle C is 114.6 degrees. You can say, well, that's a ridiculous triangle, Mr. Pines. 114.6, that's way bigger than this. 114 should be a huge angle. Whatever. I'm not going to make a big deal. You don't have to go back and redraw your triangle. It's okay. We always start a triangle to help us know what to do with the problem. Last part, find side C. So, since these are proportions, let's switch around. I want to solve for C. I want little c to be in the numerator. Little c over the sine of angle C, 114.6, is equal to little a, or side A, over the sine of 40 degrees. Multiply both sides by sine of 114.6. C is equal to 3 sine 114.6 over sine 40. Calculator to get C is equal to 4.2. Before we go to our next problem, I want to go back to that idea of how the sine of an angle can have two, or sine of an angle equals a value can have two angles. So that's an important concept here. And we've solved this equation, or we're used to this many times. The sine of theta, which is some angle, is equal to 1/2. Well, we know theta has two answers. Theta equals 30 degrees, because the sine of 30 is 1/2. And also, because here's 30, here's 1/2, the sine of 30 is 1/2. We also know that the sine of 150 is also 1/2, because 150 is 180 minus 30. Theta equals 180 minus 30, which is equal to 150. Again, using that idea to find those two possible angles for the triangle. So here we go. Our next problem is a situation when you can have two possible triangles. We've been given this information, and in the future I'm just going to say, hey, given this information, solve a triangle. Law of sines, what are you going to do? So you need to draw, I call like your starter triangle, just to see what information you are given, if it is side-side angle. So A, B, C. A is 35, A opposite side 6, B is 8. So we have side angle. Okay, the triggers in your brain. All right, watch out. This could be different solution method here. It could have multiple triangles. So I've been given a pair, an angle and its opposite side. I've been given side B. Only thing I can solve for right now is side or angle B. So the sine of B over 8 is equal to sine of 35 over 6. I don't need to cross multiply here. My variable is in the numerator where it should be. Just multiply by 8. calculator here, the sine of B is equal to sine of B is equal to, oh shoot, I didn't write it down. Where's my calculator? We got 8 sine 35 divided by 6. About 0.765. So sine of B is equal to that. This has two answers. B can equal 49.9 degrees. Or B equals 180 minus 49.9, which is 130.1 degrees. Write that here, save myself some room. So B can be 49.9 or 130.1 degrees. So I need to erase this so I have room. So we check, is that possible? Are those angles reasonable? 35, we know that's our angle we have. 35 plus 49.9, that's less than 180, so that's reasonable triangle. 130.1 plus 35 is 165.1, less than 180. So those are both reasonable values for angle B. So we have two triangles we're going to have to solve. Let's get rid of our starter triangle now. We don't need that triangle anymore. I'm going to set up two separate columns here, two separate triangles. So first I have a triangle. Let's call 49.9 degrees, let's call that B1. And 130.1, let's call that B2. My triangle. I have in triangle 1, A is 35 degrees, B is 49.9. Let's solve for angle C. C is equal to 180 minus 35 minus 49.9. Gives me an angle of 95.1 degrees. You see it's bigger than a right angle, so it's going to help us do a nice sketch for our triangle. We won't, if we can, we want to try to make the triangle reasonable. It's not a huge deal, but let's see. 35 degrees. Let's draw a 35-degree angle. I don't know, about right there. Angle B, 49.9. I don't know. That's okay. Angle C, 95.1. So about here, and bigger than a right angle, so that looks about 95, and I'm satisfied with that. A, B, C, 35 degrees. B is 49.9. C is 95.1. We don't know side C yet. We know side A is 6. And side B is 8. All we're left to do is find side C. Okay. I'm solving for the side. Since, like law of sine, sine A over A equals sine B over B. That's a proportion. You can flip a proportion and it's still equal. I'm solving for a side, so let's put the side in the numerator, and that'll save us some time. Side C over the sine of 95.1 is equal to, and let's use a 6 over the sine of 35. Multiply both sides by sine of 95.1. So 6 sine 95.1 over sine 35. And I won't write too much lower. C is equal to, we get about 10.4. Okay, let's draw our second triangle with B2 when angle B could have been 130.1. So look at angle A, 35 degrees. That's all right. Angle B is big, 130. Oh, sorry, before that, let's solve for angle C so we know what that looks like. 180 minus A is 35 minus B2, which is 130.1. This is the other triangle. Angle C is about 14.9 degrees. A small angle. Small angle. Here we go. Angle B's got to be big. Let's make it bigger than that. 131. And small angle for C, which still looks about 35. We tried. Right? We made angle B clearly a big angle, 130.1. And C, 14.9. Okay, side A is 6, side B is 8. We want to solve for side C. Again, C is the unknown. Let's put the unknown in the numerator. Side C over the sine of 14.9 is equal to, let's go A, 6 over the sine of 35. Multiply both sides by sine of 14.9. Again, I put the numerator or the variable in the numerator so I don't have to cross multiply. Save myself a step. C equals 6 sine 14.9 divided by sine of 35. Calculator, and you get 2.7. All right, our last problem here. This is a situation when you're using side, or you have a side-side angle, and you end up with no triangle or no possible solution. Again, you will be given information. Here we have two sides and an angle, and you're checking, oh, okay, I need to draw a little starter triangle just to see if it is side-side angle and not side angle side. So, draw a quick triangle. And I have C is 50. A is 2, C is 1, and C angle side side or side side angle. Okay, gotta watch out. Maybe it's 1, maybe it's 2, maybe it's no solution. We've been given a pair, an angle on its opposite side, another side. Only thing we can solve for right now is angle A. So the sine of angle A over 2 is equal to the sine of angle C, which is 50, over 1. Multiply both sides by 2 to get sine of A equal to 2 sine of 50 degrees. Inverse sine on your calculator. Well, first, sorry, not inverse sine yet. I'm sorry. The sine of A is equal to 2 times the sine of 50. Which gives us about 1.532. Now that should raise an alarm there for you, but just in case it doesn't, because maybe you're so locked in on the math, you say, okay, I want to know what A is. Go inverse sine of the answer of inverse sine of 1.532, and you get error, and you start freaking out, oh, something's wrong, I did something wrong, the calculator's broken. No. Saying the sine of some angle is 1.532, and you say, oh, that's ridiculous. The range of sine is -1 to 1. It must be between -1 and 1. Here's the graph of sine. Goes up to 1, down to -1, up to 1, down to -1, and so on. So the sine of some angle cannot be bigger than 1. There is no triangle, no solution. No triangle. Or impossible triangle. Impossible triangle. The other day in class, they say, surprise, I like this law of sine stuff. I feel like, it's going pretty well. I'm doing good. And I said, well, it's a good sign. I don't think that's funny. It's a bad truth.